Welcome to The Explainer. Today, we're diving into the world of statistics to answer a really simple but important question: how do you know if something is fair? And we're going to do it by cracking the case of the chi-square test.
So, let's set the scene with a little mystery. Imagine you're a school principal. You've got this gut feeling, right? It just seems like way more students are out of class on certain days of the week, especially Fridays. But a hunch isn't proof. How can you know for sure if absences are really uneven or if it's all just random chance?
Here's our game plan for solving this little puzzle. First, we'll pin down the actual problem. Then, we'll lay out the two competing theories. After that, it's all about gathering evidence, running the numbers, and finally, delivering the verdict. It's a 5-step journey to the truth.
All right, so let's get into it. It all starts with that central question. The principal suspects that absences aren't random, but we need to move past suspicion and use cold, hard data to see if there's a real statistically significant pattern happening here. The tool we're going to use is the chi-square goodness of fit test. Now, don't let that name scare you. The idea behind it is actually beautiful and simple. All it does is measure the gap between what we expect to happen in a perfectly fair world and what we actually see in our data. It's basically a reality check.
Okay, so let's get official. Before we even peek at the data, a statistician has to frame the investigation properly. And that means laying out two possible outcomes, two competing stories about what's really going on.
Now, this part is absolutely crucial. We always start by assuming fairness. Think of it as the innocent until proven guilty rule of statistics. This is called the null hypothesis. We assume absences are spread perfectly evenly. Our whole job is to see if we can find enough evidence to prove the other story, the alternative hypothesis, that nope, something fishy is going on and it isn't fair.
So what did the principal actually find out? Well, they grabbed a random sample of 100 recent absences and just wrote down which day of the week each one happened on. This is our real-world evidence. These are the facts on the ground. And here it is, our evidence table. That observed column, that's what really happened. The expected column, that's what a perfectly fair world would look like. Exactly 20 absences each day. You can see the differences right away, can't you? Only 14 on Wednesday, but a whopping 28 on Friday. So the question is, are these differences meaningful, or is this just random noise?
With our evidence in hand, it is time for the analysis. We need to take all those little daily differences and basically boil them all down into one single number, one score that tells us exactly how much our reality strayed from that fair world expectation.
We're going to do this in 3 really straightforward steps, I promise. First, we'll figure out something called degrees of freedom. Second, we'll find our critical value. That's our threshold for proof. And third, we'll calculate the actual chi-square number from our data. First up, degrees of freedom. It sounds kind of complicated, but it's not. Think of it this way. If you know that total is 100 absences, and you know how many happened on Monday, Tuesday, Wednesday, and Thursday, well, the number for Friday is already decided, right? It's not free to be anything it wants. So even though we have 5 days, only 4 of them are free to vary. The math is simple. Just take your number of categories, 5, and subtract 1. That gives us 4 degrees of freedom.
Next, we need to draw our line in the sand. In statistics, this is called the critical value. It's a threshold we set before we do the big calculation. We're going to use a standard 5% significance level, which basically means we want to be 95% sure that any pattern we find isn't just a total fluke. So we use that and our 4 degrees of freedom to look up a value. This number is the score our data has to beat.
And for our case, with 4 degrees of freedom and that 5% level, our critical value, our official line in the sand, is 9.49. Remember that number, it is the target.
And finally, the main event. Here's the formula, but don't get hung up on the symbols. Here's what we're actually doing. For each day, you take what you saw, subtract what you expected, square that result, and then divide by what you expected. We square it to get rid of negative numbers and, more importantly, to make the big differences count for more. So for Friday, that's 28 minus 20, which is 8. Square it, you get 64. Divide by 20. We do that for all 5 days and then just add up the results. That's our final score.
So, after we run all those numbers from our evidence table, the 23 for Monday, the 16 for Tuesday, and all the rest, and we add it all up, our final chi-square statistic is 6.3. This single number represents the total amount of weirdness or deviation in our data. And now, the moment of truth. We have the score from our data, and we have the target we needed to hit. Let's see if the evidence was strong enough to make our case. So here it is, side by side.
Our result, calculated from the principal's real-world data, is 6.3. The critical value, that line in the sand we had to cross, was 9.49.
As you can plainly see, our result of 6.3 did not cross the line. It fell short of that 9.49 threshold we needed to declare that something significant was going on.
So what's the final verdict? Well, in the official language of stats, we fail to reject the null hypothesis. Now, in plain English, what that really means is that even though it looked like Fridays had more absences, the overall variation across the week just wasn't extreme enough to be statistically significant. The principal's hunch was just that, a hunch. We just don't have the proof to say that absences are happening unfairly.
So, what's the big takeaway here? The chi-square test is an incredibly powerful tool for checking if the reality you're seeing actually matches up with your expectations. You can use it for anything from customer preferences to election results. It helps you separate the real meaningful patterns from what's probably just random noise. So, I'll leave you with this. What patterns in your own world would you want to put to the test?